All right, so here we are in the next step of our introduction to R Studio and the R programming language. I had mentioned that I wanted to introduce you to basically the platform for R Studio, the help file, the cheat sheets, and for you to familiarize yourself with this environment. But that being said, I want to emphasize the fact that this is just a lot of you could say falderall sitting on top of what is a kind of a bare bones programming language. And in fact, you don't have to install RStudio. There are other kinds of wrappers. I prefer RStudio. I like it. I'm used to it. There's a R Commander out there. I'm sure there are others. There's Rattle, which is an interesting GUI or graphical user interface for machine learning. But base R is what we're going to talk about today. And I'm going to actually show you what this looks like because you have base R installed, and this is what base R looks like on Macintosh computer in this version. And you see that I have both versions installed. In fact, one common problem I've seen students encounter is when they install R and then they install RStudio, and let's say they have this script file. So that here we have a script here. So here I have both of these programs installed, and I have my code here, my empty code and my empty little script. We have our little tips code here. You see that I actually, if you actually didn't see this, but let me put this on the desktop. If I take this little guy here, this code here, RStudio is complaining because I moved this script out of this folder. But if I take the script file, RStudio will open it. As long as you set RStudio as the default. However, typically when you first install base R and then you install RStudio, a lot of students will actually just double click the icon or double click the file, and it will not automatically open into RStudio. It'll actually open automatically with what is it? This other base R. And I want to show, so the way you get around this in the Macintosh environment is you essentially do this, you right click or control click the icon and you get information on it. So you do get info, and then you say, okay, you want to use the file here, open with, and then you want to name it. So here I am going to just default to change all. I'm going to change it so that every time you have a .r file, this is the suffix for a script in the R environment, it'll open with base R. Now, of course, we don't want to do that. It asks me if I want to save that, but here I'm going to show you what happens to a lot of students. They open this and then they open the script, and if you notice, this is one thing I kind of like about base R. You have the console here and you have this liberated script file right here. It's not pinned. Now this is just a matter of taste. I actually like RStudio for many other reasons. But what I want to point out is everything that we're going to do here, you can also do here in base R. But let's stick it. Let's actually get out of base R, and let's get out of the habit of opening that, because I think there's a lot in RStudio that works. We just want to make sure that that when we open files, we're going to actually set the default to RStudio and not to R, because R is just going to sit there in the background. It's sort of the it's the machinery. It's behind the counter. Okay, so if we get to base R, I want to show you the base R cheat sheet. This is a great one that we looked at in the first video, and I'm just going to walk through some of these. I'm going to type these out. You can actually look at these and follow along, but I think it's useful. I encourage you to actually type and work your way through by typing and by actually experimenting with some of these. We're going to look at this dastardly data set called the IRIS data set because it is so common, and you'll see it here. But the first thing you want to know is that when you type in R, when you work in the R environment, you'll see that my script turns red whenever I change it. But you see if I press carriage return or enter on my Mac, it'll actually it'll index the number of lines that I have in the script. So that's pretty cool, right? Simple little thing. You'll see a little asterisk and a red sign there. So we want to save this on a Mac. You do Command S to save this. I just saved it right where I placed my little code, my modest code here. And the first thing we're going to do is we're actually going to say how to get help. Well, the first thing we do before that is if I type get help, you'll see that RStudio is quite helpful here. It's a lot like, I guess, Python and even SPSS. It'll have drop-down menus where you can press F1, and you'll see that already RStudio thinks that I'm typing a function. That is, I'm telling it to do something. I'm not, though. This is a comment. How do I write a comment then? Well, you can highlight this. You can do, I think, Shift Command C. That's a keyboard shortcut. Or you just put the hashtag there. But the nice thing about having this is that you can just comment out lines, and you can actually type out a lot right here. So the quick, you can type out quite a bit. So you can accessing the help files. And then if you want to type out more about an object. And I'm just going to ignore these yellow pop-ups. You'll see that RStudio is really complaining. It's really seeing these as erroneous functions. But in fact, I can do my keyboard shortcut Shift Command S, and I can comment these out too. If I highlight these, I can do that. I should be able to. Why is that not working? Maybe actually, you know why? Well, that's not fun. Perhaps there's something, I'm not sure what's going on here, but you can actually just type it the old-fashioned way. You can comment it out. For some reason, my keyboard shortcut didn't work. I'm not sure why. It doesn't really matter. You'll see that sometimes things go awry. It's not the end of the world. But you'll see that in this version of the RStudio environment, in my version, which is the default, you'll see the commented lines in a different color than the actual functions. And the functions are always going to be some little bit of text within, and then it'll reference something that it's manipulating in single quotes or in double quotes within the brackets. I'll show you what I mean here. So the function that I'm going to introduce you to first of all is this help function, and this is how you type a function. A function will have this. Essentially, this is the structure of a function. You have what it is, right? This is help. I need somebody. Like the Beatles song, you have the little brackets, and if I highlight one, you'll see that it kind of wants to autocomplete, and they kind of want to finish each other off. So we'll just look at a basic function. This is we can look at the what's one of the most essential functions. Well, let's help actually. If I do this, I don't think you necessarily have to have it in quotes. I just did a Control Shift, and I'm going to click this Run button. But you can also just click on your cursor at the end of the line, and then click I think Command L. No. Well, we'll just click Run here. Sometimes I forget the keyboard shortcuts when I'm switching between a PC and a Mac. I apologize about that. But if you look at this, you'll see that what we did is we just actually opened up the documentation. So that's what the help function does. It actually opens up the basic documentation. And there's a certain structure to the documentation for a help file. It'll look like this. It'll look pretty ugly at first. If you're not used to programming language, you'll see this gobbledygook here. This is the argument. This is the full, this is the full phrase. This is the full, you could say, verbose version of the actual function. And a function is bound by, typically bound by parentheses. I keep saying brackets, sorry, parentheses. And it'll be demarcated within those parentheses by commas here. So here you have a help about a particular topic where the package is set to null. This is equal sign within R. It takes on a particular case. It's more often used within arguments and not as an assignment or operator or as a way to define objects. We'll talk about that later. There's something called the assignment operator. It's considered bad form to use an equal sign to assign objects to certain characteristics. But the main point here is that you have this sort of help file here. Okay, so that first thing to get help on is you might need help you can type it within the console. This is base R again. Remember, you can go do this in the raw version of R. I'm going to delete that here. You can also just type question mark and help itself, and that should work too. And again, you'll see the same thing. So you can type this in the console. I'll do this if I'm being lazy and I don't want to write out in the script. I'll just do that. I'll type it out. Now, if I do a double question mark, you'll see something else. You'll see search results that arise. These actually are within my, looks like these are within my set of packages that include references to help. Not always that useful, but a double question mark is different than the single question mark. But essentially finding help is probably the best. If you want help for a particular function, you do help here. Let me show you help for mean, right? So the mean function is to find the average. It's a basic mathematical function. There it is. It's arithmetic. It's even considered a base function. You can see this little bracket function as it's a base. So question mark in front of that is essentially in front of that function. It doesn't need those parentheses, and although it doesn't matter, it'll just give you the same output. You can do this in base R. It won't look any different. So do the question mark, do the help. It does the same thing. Just it's all a matter of style. This is going to be a kind of a recurring issue in R. You're going to see a million ways to do things, and you're going to see, the version that you decide to do it may not be, the same for everybody. Okay. Now, what if you want help for a particular package? If you want to help, if you want to do like a sort of broad search for help for a particular function, let's say we want to do a, I don't know. I'm going to try geometric mean. Let's just try this. Help search. I'm just guessing here. We're going to do, you can do singular quotes. I just did a little tap there, and it auto-completed for me. And I'll do harmonic mean. We don't do enough harmony here. It's a kind of mean there. And look at this. You use something called the psych package. And within the psych package, they actually include a function that is a harmonic mean of a vector. We'll talk about that later. A matrix or columns in a data frame. Data frame is just R speak for a spreadsheet or tabular data set. It's something with rows and columns. It's a data set. But you can do that for anything here. So that help search function is a broader search. So let's comment that out. We'll just say sort of a broad search. Broader search. So that's important to know. Now, that's about it I think we want to know for now, except the fact that you might want to also know about particular objects within your environment. But before we do that, we want to probably, I will do this. We'll look at the structure function. This follows the base R cheat sheet available in the RStudio download. So we'll do this, but this is okay to do. So typically, if I would use this kind of function if I wanted to look at the dimensions of an object, or I wanted to see what its shape was. It's a structure. So this is the structure of an argument. Sorry, of an object. Remember, so we haven't really even defined what an object is. Right, for now, just use it as a placeholder. An object is just something out there. It's a letter, it's a data set. Think of an object as a data set, probably. But so we'll look at this one. This is the famous IRIS data set that I mentioned earlier. The IRIS data sets here, if you do the structure here, you can see essentially it tells us what it is, what it consists of, and several attributes, and it gives us some examples here. So remember, as I said before, in R speak, a data set we call them data frames. And if you look at the way this is put, the output is presented here. When you look at the structure of an R data set, you'll see in the first row in the console here, this is just printed out. We're doing nothing here except printing out some information. You'll see what kind of object it is. There are different kinds of objects. A data frame is a particular type. It's a data set in which you have observations as the rows, and the columns are the variables. So we already know that it has 5 columns and 150 rows. And now we know the attributes and the names of those columns. So that those columns are sepal length, sepal width, petal length, petal width, and the species. And then now we get to see the structure of this data set, this famous data set. These are, I suppose these are flowers. I don't really know the background of this. I'm a sociologist, but you can see that this consists of 4 numeric variables. That's what this NUM means. These are just, countable. And then what R likes to call a factor variable. This is the origin. This is essentially a qualitative variable or categorical variable. That means, that is to say, there are 3 types of species here. So that's what these 3 levels here represent. We have Setosa, Veris, Color, and it looks like these are perhaps indicated by these 1s here. But that's what the structure argument does here. And if you want to know more about this is useful to do. You can just do this little question mark here. And I actually like the help file here more than my own explanation, because it says compactly display the structure of an arbitrary R object. Arbitrary is a good word here because it can be anything, and STUR is how you remember the word structure. Now, like anything else in R, there are quite a few options, but the nice thing is you can look at, typically you can go down to the bottom and see these examples. And let's see if there's an example here with, you see some mathematical examples. I'm going to see if there was one with the IRIS data set. Quite often with examples, you can actually, how do I put it? Quite often with examples, you can actually just copy and paste these. If you can see, here's a double hashtag. This is actually a comment. And these require arguments. These are loading the packages into the environment because they're required. So you can actually do this. You can actually just, if you really want to do this, you can actually copy and paste some of these examples, and they should work. But I want to get down to look at the structure of a structure. We're being quite kind of reflexive today. And we'll see if those actually worked. Yeah. So you'll see that the structure of the structure function is a function where an object is, I guess, defined as a structure of sorts. But you can also say, maybe if you wanted to, you can define an object here too. I think if you looked at this example here, we did a structure where you have a list of numbers going from 1 to 12, and that's what it is. It's a set of integers. You're essentially defining. This is pretty redundant. You're saying in R, this colon here is basically a sequence operator. So it says that we're defining something as a sequence of 1 to 12 inclusive. And then we ask what it is with the structure function, and it says, well, it's an integer. It's a vector because it's a list or a line of these numbers from 1 to 12, and it'll show us most of them, but then it gets kind of bored, and then it'll give us an ellipsis for the 11 and the 12. So there are different kinds of things. You can define an object as anything, but the point is structure is a very good way to know about your environment. Now, the other thing is you also might want to know this thing called class. I know some of us have it, some of us don't. Some of us are born with it, some of us aren't. I'm not talking about that. I'm talking about class. Essentially, every object has its class. So in R, there are different types of classes for objects. As you might imagine, this iris data frame or data set is going to be a particular class. And we'll talk about this later, but just remember that most of the time in data analysis, we're going to deal with data frames. We're going to load data frames. We're going to deal with data frames. We're going to get headaches with data frames. And that's the class there. There are other kinds as well. As I said before, there are things called vectors. There are different types of data. There are logical, numeric data types as well. But just keep in mind that class will tell us about the kind of the, how did I put it, the class of an object. So every object has a class. So if we want to know more about class, how many classes are there, you can see that so they call these S3 classes and methods. This is a little bit technical, but essentially, it says below in this argument here, many R objects have a class attribute, a character vector giving the names of the classes from which the object inherits. This is a bit much, I think, if you're not familiar with the jargon. If the object does not have a class attribute, it has an implicit class, matrix, array, or the result of mode X. The point is that you can create anything as an object in R. So I can just basically create anything in my environment, and that environment will be put into a bin. It'll be classified, and that's what the class is. So if you don't know what you're dealing with, you can at least know its essential structure. You can know its class, regardless of what it is. And if it's a function and it exists in the R universe, you will know what it is by accessing the help file, or you will be able to find anything you need to do within R using this help search function. So these are essentially ways to, if I imagine my first day when I was using R, and I wasn't really a born programmer, I was a sociologist, I felt like a vole. I was blind, and this will help you see within the R environment. So just to end on this, we can do quite a bit of other examples of help searches. We can think of other things to look for. Just to give you an idea, let's look up neural net. Let's look up since the neural networks are kind of popular these days. Let's take a look at that. And you see that here we have some log linear models. We have a Hessian neural network. We have an net function. So you can see that there are functions for neural nets. Maybe there's something for learning R. I would say you can basically look up anything here. Yes, learning vector quantization. Well, you don't need to know this, but maybe, I don't know. Just essentially anything you could think of, you could probably look for within the R environment. Plot is a kind of a common function. You might want to get used to this. Plotting functions, this is the nice thing about RStudio, is that you have something called vignettes. We haven't really talked about this, but within some help files, you'll have what are called vignettes. I'll always encourage you to go to the vignettes, because the vignettes are essentially what you say in French. It's the story, and it tells you the story with the code. And this is really just radically easy to do. You can basically, as I read in some blog today, the blogger was complaining because you don't have to be a genius to do a neural network. You could just copy and paste, as a monkey see, monkey do, as they say. And here we're doing a dendrogram, which is a type of cluster analysis. And it looks like it has some requirements here, or what are called dependencies. That's okay. I probably didn't download all of the stuff here. Yeah. I needed the initial commits here. These are the library function here. You probably also have to install these. I don't really care about that. So, but the point is, you can basically do anything. You can do a lot of cool stuff, and you can just copy and paste. And I already have 100 lines of code. So quite a bit of it's just junk. But the point is, we've learned about the class, the structure, and we've learned different ways of finding help within R. Next, we're going to look at packages, and we're going to look at first of all, I think what we're doing here is we're kind of use the blind vole metaphor. We're essentially defining or understanding what it is in our universe. What are these things? Next, we're going to talk about using packages. So these are, as I said before in an earlier video, this is the bread and butter. This is This is the kitchen sink of R. This is what makes R very powerful. It has a plethora of packages, and packages are essentially like the Library of Alexandria. It's whatever you can do or want to do. There's probably a package written for it. Probably too many packages written for it. There are probably some bad ones written for it. There are a lot of different packages, and a package is a bundle of code for a particular task. And essentially, packages, I think of it as a library. Metaphorically, think of it as a library. You're building a library, and sometimes you have to install that library. So that means buying the book, and then you have to, every time you want to use a package, you want to load that library or that package, and you want to require that package or use that package, which means that you actually pick up the book. So we'll talk about packages later, and then we'll also talk about working directories, which is essentially where it is you're placing your analysis. So packages are what you're going to do, and then working directory is where you're going to do it. We'll talk about that in the next video. Thanks a lot. I hope this has been useful and fun.